Okay, so we have started with our module 1, and I hope you're reading the module. Okay, as we have said, our synchronous class is just some sort of additional information to the module that was given to you, and the link that was posted to one of the lectures that I have that discuss the topic on the module. So today we're going to have 2/3 of the module. So we have started already last time with regards to the electromagnetic radiation. We end up with the Bohr atom. Okay, so when we're talking about the Bohr atom, okay.
Kay Sir Mohika ka rin? Sir Mohika?
Hoy. Pakimute naman, please. Kasi naman yun.
Sorry po, sir. Sorry po.
So, we have started what we call discussing about the dual nature of light. Okay, and I think we end up with the what we call Bohr atom, wherein Niels Bohr predicted, or we could say proposed, that atom similar to the planet in the solar system, wherein there are energy level where electron, when absorb energy, they go to a higher energy level of the what we call orbits, and when they go there, they're unstable. So after some time, they will go back to the lower energy level, which is, we could say, the ground state. Okay, now we can extend the dual nature of light, okay, by looking at an electron. Okay, so the dual nature of light, where the original description of light is what we call a wave, and then the Planck revolutionary explanation for the black body radiation suggests that you can quantize light and make it into a particle. Okay, now that same concept, you can also apply it, let's say, in the electron. So why could we say that the electron can be what we call its energy quantized? Okay, so if the electron is quantized, that means it can also behave what we call, just like the light, to have a dual nature. So usually electron, they are particulate in nature. So if the electron energy can be quantized, that means it can behave like a wave. So let's say this is what we call the electron, the whole circle here. So if it's going to be what we call energy quantized, it has a wave-like property. So Louis de Broglie proposed the dual nature of matter, wherein he said that electron can behave both as a particle and a wave. And you can observe this pattern. I don't know if you're familiar with the guitar. So if you pluck a guitar string, okay, you will see some sort of the wave-like property. I don't know if you observe it. Nakita nyo ba, let's say kung meron kayong guitar string, pag pinak ninyo, makikita nyo yung parang wave-like property niya. Okay, so yun yung explanation ni de Broglie na matter, although here specifically said electron, can behave not only as a particle but also like a wave. Okay, and one thing we could say that you can look at this is the application of these wave-like properties of electron. Okay, I'm not sure if you're familiar with the electron microscope. So the electron microscope take advantage of the wave-like property of electron to magnify the object that you look under the electron microscope. Ang basic principle doon yung tinatawag nating diffraction. Okay, so if you're going to look at it into mathematical model, so you have here, if we have 2 pi r equals to nh, or not n, n lambda, and you can what we call lambda be equals to what? H over mass over times what we call the velocity. So H there is what? Planck constant. Okay. M is the mass of the electron and then the velocity of the electron. So ito yung magbibigay sa kanya yung tinatawag nating wave-like property. Okay? The only thing that we cannot observe the wave-like property in some instances because it is not within the so-called visible region. So if you do some calculation similar to this one, so like a ping pong ball, so you have 2.5 grams of the ping pong ball traveling at 15.6 meters per second. Okay, you can look at the wave-like property of it. And as you could see, okay, if you do the calculation based on this one, so H is what? Your Planck constant, and then the mass that is equals to your 2.5 grams, and then the velocity, which is equals to that. So if you're going to replace the values there, so this is what you have. Planck constant divided by, so the mass there you have to convert into kilograms, and then meters per second. And if you're going to calculate it, this is the wavelength. And as you could see, it's very short. So you will not be able to observe, okay, its wave-like property. So that's the explanation that they have there. Okay, but at least what happened here is the nature of light being dual in nature was extended to electron or in general matter. Okay, and this is, we could say, responsible for the next model of the atom. Why did the Bohr model fail? Bohr model was able to explain the line spectra, okay, but the Bohr model wasn't able to explain, or we could say Bohr model is not applicable beyond more than one electron. It's only applicable for hydrogen, okay? But beyond that, it is not what we call applicable. So there are some, we could say, limitation with regards to the Bohr model, okay? But what happened during that time, a guy named Erwin Schrodinger developed this what we call wave equation. So what Schrodinger did in 1926 is he wrote an equation that describes both the particle and wave nature of the electron. So here he's applying the concept that was proposed by Louis de Broglie. Okay, so in terms of the wave function here, he described it as the energy of the electron with a given wave function. Okay, and this wave function describes the probability of finding electron in a volume of space. Okay, so if we're going to look at the Schrodinger equation, it can only be solved exactly for the hydrogen atom. But if you what we call apply it to multi-electron system, you have to do some sort of approximation. Okay, so what is the advantage of this one? So at least it be able to tell you where the electron is in a given atom. And then in addition to this, okay, there's another guy by the name of Heisenberg, Werner Heisenberg. He proposed the so-called uncertainty principle. So in an uncertainty principle is described the dual nature of the electron. Okay, it states that it's impossible to know simultaneously both the momentum and the position of an electron. So you can only predict one of them at a time. You cannot predict both of them at the same time. Okay, so this becomes the basis of what we call the quantum mechanical model. When you put them what we call together, okay, using Schrodinger equation, when you go to, I think, Chem, you will 115, they will have like a Schrodinger equation. Okay, you're going to solve a lot of this mathematically. But what the Schrodinger equation gave us is some sort of a wave function as being a function of your four numbers, which we call the quantum numbers. So the Schrodinger wave equation tells us, okay, the approximate location of the so-called electron in a given atom. Okay, so if we're going to look at this, what we call Schrodinger wave equation, it gives rise to what? This concept of the orbital. So more or less, it's still adopted the concept of Bohr called the energy level as what we call orbits. Okay, but what Schrodinger do is adopt that concept and call the probability where you can find the electron as what we call the orbital, and each orbital can at least be described by the first three quantum number. Okay, so the quantum number that describes here, the first three quantum number, it just tells us the location of the orbital in a given atom. It's just like an address. Okay, so we're going to discuss about these quantum numbers today, and I think that's all the topic that we have for today. Okay, quantum numbers. Ayoko na kayong maano agad eh. Okay, and next meeting on Thursday, we're going to finish the module by discussing periodic table. Okay, so let's try to look at the first what we call quantum number. Yung tinatawag nating principal quantum number. Okay, I always call these quantum numbers as the S, because I can describe it with the S. If you watch my other lecture, you will know what are these S. So usually the principal quantum number refers to the size. Okay, and the value of the quantum numbers are usually what? Positive integer. Okay, and it describes it as the distance of energy from the nucleus. That's why I told you it refers to the size. So the higher the n, the bigger is the size. Okay. So usually if you have this what we call principal quantum number, it gives you idea, okay, on the size of the given orbital. Okay. And if you're going to look at this is n1, n equals 2, n equals to 3. But if you're going to look at this one, if you have this what we call orbital, so in the orbital, that's the location where you can find the electron. I think the best way I can look at the quantum mechanical model, you know an electric fan? Alam niyo yung electric fan? Di ba may blade siya? Once it starts to rotate, can you locate where the blade is? Let's say I put this blade. Can you monitor it once it starts to turn? Yes or no? The exact location of it. Can you tell it? Okay. The exact location. So habang umiikot siya, kaya mo sabihin, oh, nandito yan. Most likely not. Right? But the probability, where you can find it, you can at least what we could predict. Yeah, merong naka-ano. Naka-mute. So you cannot predict the exact location of it once it turn around, but you can pinpoint the possible or the probability of its location, but not the exact location. Iyan yung sinasabi ni Heisenberg that you cannot simultaneously predict, okay, the momentum and position of the electron. Okay? So, ganun yung parang ano ng quantum mechanical model. I always call it the electric quantum model. You know where the location. So, try to imagine that this blade are the electrons. So, once it turns around, okay, you can tell the probability where it is, but you cannot pinpoint the exact location. Okay? And if you're going to look at the radial probability that it is, okay, so from a certain distance from a nucleus, okay, so the probability that you have will increase, and then it will going to decrease again. Okay, and if you're going to look at this, it still follow like this: n equals to 1, n equals to 2, n equals to 3, but the difference is the size. Okay, so if you have the principal quantum number, it's usually just a positive integer. Okay, the size. Now the next quantum number refers to the azimuthal or the angular quantum number. So this is the L. And unfortunately, the L value depends on the N. Okay, L is equals to 0 to N minus 1. So when the value of your N is equals to 1, the value of your L is just 0. When the value of your N is equals to 2, your L value are what? It's either you can have 0 or 1. Yes, question. May nag-raise ng hand. So if you're going to look at this, those L value refers to something. Those L value, okay, if it's equals to 0, that refers to an s orbital. When it is equals to 1, that refers to the p orbital. When it is equals to 2, that refers to the d orbital. If it refers to L equals to 3, that refers to f orbital. And as I've told you, I usually describe the quantum number in terms of s. So this refers to the shape of the volume that occupies the electron. And I can describe the shape based on the letter that you have here. Okay, so I'm going to show you how the s orbital looks like. So the s orbital would look like this. So ano pwede nating ipangalan dyan pag s?
Sphere po.
Spherical or sphere. Okay, if L is equals to 1, it is a p value. So ano pwede natin ipangalan yan na start sa letter P?
Peanut po.
sir.
Napanood niyo yung video, no? Tapos kapag D, ano? Sa nanood?
Double peanut po.
Double peanut, sir.
Double peanut.
Nasa lecture ko ba yun?
Yes, sir.
So you see, spherical, peanut, and the double peanut. Tawan-tawa yung mga Amerikano dito pag inaano ko yan eh. Pag F, although we don't have F, ano yung description ko dun? Flower. And I think in the lecture, you see the shape that really what we call show how it is. So at least it shows that you watch the video. So kahit hindi man lumabas sa quiz, I can assure myself that you're prepared for the exam. Okay? Because I think the way that even if I meet you for 30 minutes, at least it keeps you on what we call on your feet, that you're ready to prepare and you're always forced to what we call read. And I think it's one way to tell that para pa rin tayong tawag dito, face to face. Okay? Oh, doon sa mga bago, I want you to stay, and just to let you to inform you, okay? Gabi pala dito sa anak ko. So in case you don't know, I'm not based in the Philippines. We have some new students who just joined us today. Okay? So that's why makikita nyo sa background ko merong parang halo na light. Okay? Hindi po ibig sabihin na angel ako na may nag-sunlight dyan. Meron hong ilaw sa likod ko. Okay? So welcome dun sa mga nag-pre-rob. I was able to accept you kasi yung mga walang pangalan na wala na sila. Okay? And usually what happened is they allow us to accommodate up to 33 students. So as of now, how many do we have? 30. So there's 29. Okay? And I want the new one to stay after we're done. Usually we're not going to finish the 1.5 hours. And usually we have a quiz afterwards. So yung quiz natin ngayon, may prepare kayo ng calculator, may isang calculation doon. Okay? So, meron na tayong size, meron na tayong shape. So the next one would be the magnetic quantum number. So that's the M sub L. So as you could see, each of the quantum number are related to one another. Okay, or if the L is related to N, the same thing with the M sub L. Okay, so usually in an M sub L, it depends on the given value of L. So if your M sub L, okay, is equals to, we could say, -1, -0, +1. Okay? So that means, paano natin aanuhin yan? So M sub L is just equals to -L to +L, including 0. So paano natin ipo-formula dito kung ilang value ng M sub L based on the given L? Paano natin na ano yun? Yes, Rex.
2L minus 1 po.
Okay, so 2L. 2L, is it -1 o +1?
Plus 1 po.
Okay? So, yung value ng given M sub L just depends to this one. So if your M sub L, so if your L is equals to 0, yung M sub L mo, isa lang yung value, di ba? Because 2 times 0 is equals to 0 plus 1. So meron kang isang value dun. At yung M sub L value ay 0. Okay? Remember, your M sub L values range from the -L to the +L, including 0. So kung ang L mo is equals to 1, so yung M sub L mo is -1, 0, +1. So this is 3 values. So from here, 2 times 1 plus 1. So meron kang 3. Okay? So if you're going to look at this, ano naman yung S dito? Sabi lang dito, orientation of the orbital in space. So usually, doon sa isang lecture ko, I put the S here. Yun yung tinatawag natin spatial orientation. Now, ano yung information na makukuha natin dito? I-relate natin yan doon sa shape. Diba? So, kapag ang L mo is equals to 0, ibig sabihin yung M sub L mo is just 0. So, ito lang yung meron siya. Okay? Sa S orbital. Now, if your L is equals to 1, anong ibig sabihin yan? So, meron kang -1, 0, at +1. Yan yung tinatawag nating orbital. So, pwede natin i-refer to kapag sa p orbital, ito yung -1, ito yung 0, ito yung +1. Now, kapag meron tayong L is equals to 2, so you have your M sub L, -2, -1, 0, +1, +2. So, pwede mong i-assign yan. So, yan yung tinatawag natin mga orbital. Okay? So, if we go on, I think, inuna ko dito sa handout ko. So, kapag ML, okay, is equals to 1, meron kang 3 orientations in space. So, ito yung 2px, 2py, 2pc. Okay? So, depende kung nasaan yung mga electron mo. Okay? If you have this L is equals to 2, meron kang 5 orientations. So 3dx² minus y², 3dc², 3dxy, 3dxc, and 3dyc. So there's 5 orientation in space. Later on, you will understand what it is. Okay, so usually ang mangyayari dyan, ito yung orbital. Okay? Ito yung orbital, ito yung subshell, ito yung shell. Okay? Now, the fourth one, yung M sub S, yung spin. ang value ng M sub S is either positive 1/2 or negative 1/2. It has something to do with the clockwise or counterclockwise. So ito lang yung value niya. Okay? And as I've told you, this tree tells the location of your orbital. And this quantum number, it just tells you that in a given orbital, there is no set of the same quantum number. Kasi each orbital can accommodate at most 2 electrons. At magkakaiba yung quantum number set nila doon sa last quantum number. Okay? So, ang nagdidictate doon, so before I go there, so this was found usually when they try to look at the magnetic property, and they found out that electron has opposite spin. Okay? So, based on the Schrodinger wave equation, that where these quantum numbers came out. Okay? So the existence and the energy of the electron in atom is described by its unique wave function. So this is a product of this wave function. You will learn about it. I think you're going to do some problems of it when you go to Chem 3. Okay? And as I've told you, you can have the same set of the first 3 quantum number, but you always have the last set. The last quantum number different. And the one that dictates that is the Pauli exclusion principle from Pauli. That no 2 electrons in an atom can have the same 4 quantum numbers. That's why, as I've told you, parang address yung first 3 quantum numbers. So if you are in a concert or watching sports game, so yung mga seat doon uniquely identified, and you could say each seat can hold only one individual at a time. Okay, so yun yung story. Now, the thing that we need to do is how are you going to, let's say, solve some questions that deals with quantum numbers. Okay, so if you have it like this one, so you could see that if you have a 1s, kapag inano mo yung orbital na yan ng 1s, meron kang at most what? 2 electrons. So how are you going to assign the quantum number there? So you could put 1, 0, 0 plus 1/2, and the other one's 1, 0, 0 minus 1/2. So both of these refers to 1s. But the 2 electrons are differentiated by the 4th quantum number. Okay? So if you have what we call the 2s, ganun din. So if you have a 2s, it is what? 2, 2, 0, 0, 0 plus 1/2 and then plus 1/2. Usually ang 2s ito lang eh, right? The first quantum number, the first 2 quantum number. Okay? The second quantum number that you have there, the N and L. So this is always a number. Okay? And this is always what? A number that is represented as either S, P, or D. Okay? So, as I have told you, the N usually it's electron with the same value of what we call N, that's the shell. Tapos, yung subshell, this is the electrons with the same value of N and L. So when N is equals to 1, ano lang yung subshell niya? Meron na siyang S subshell. When N is equals to 2, meron siyang S tsaka P subshell. So itong S and P, ito yung what? L. Okay? Now, in a given subshell, you can have there the orbitals. So this is electrons with the same values of N, L, and M sub L. So ito yung mga questions na pwede nyo. How many electrons can an orbital hold? So usually, an orbital can only hold what? 2 electrons. Now you can ask the question, how many electrons can be found when n is equals to 2? Ano yung sagot nyo? Okay? So, whenever you are asked here, how many electrons can an orbital hold here? N is equals to 2. So, all you need to do is look at the L. What are the L values when n is equals to 2? You have a 0 and a 1, and that's it, right? And this one, it has how many orbital? 1. And this one has how many orbital? 3. So you have 4 orbitals there times 2. So this is equals to what? 8 electrons. Ganon yung mga tanong. Okay? How many electrons can let's say n equals 4 hold? Or how many electrons can L equals 2 hold? Okay? So paano yung ano dyan? May shortcut ba dyan? Or you can even have a question there. How many orbitals are there when n is equals to 1? When n is equals to 2? Meron bang magic formula dyan para sagutin yan? Kung napanood nyo yung ano? So ilang orbitals when n is equals to 1? Ano yung formula niya? So to get the number of
N
orbitals,
squared.
it's just equals to what?
N squared po, sir.
N squared. So to get the number of orbitals when n is equals to 1, so 1 squared is just equals to 1. Okay? When n is equals to 2, 2 squared is just equals to 4. So what is the orbitals that you can find there? The s orbital, 1, and the 3 p orbitals. So 1 plus 3 is equals to 4. Now, how are you going to utilize this formula? Let's say kung electrons na yung tinatanong. So whatever you get here in your n squared, when it is n equals to 2, all you need to do is what? Multiply by 2. Okay? Now, paano naman kapag ang tanong sa inyo is how many electrons are there at ang binigay sa inyo yung L? Is that a formula there? So let's say L is equals to 0. Anong formula ang meron doon? Ito yung dapat na paghandaan nyo sa exam. Those are the short formula. So, how many electrons are there kapag L is equals to 0, L equals to 1, or L is equals to 2? Is there a formula for that?
Meron po, sir.
Okay? So, meron. Ano yung formula?
2L plus 1 yung quantity po, i-multiply sa 2.
2L
Plus
plus
1 po.
1.
Tapos multiplied by 2 po yung buong quantity.
Ganon?
Opo.
Okay? So, you can use this for the electrons, but if you're asked, let's say, how many orbitals are there when L is equals to 0? Pag orbitals naman. So when that happens, you just use the 2L plus 1. So ano, makakaasa ako sa inyo, sure points kayo pag may lumabas na ganyan sa exam. I'm preparing you to understand the concept para pag exam, madali na lang sa inyo. So you have the module, you have my notes, my what recorded lecture at tong session natin ngayon. So I'm hoping that, okay? Pagka-exam, chicken yung exam, hindi kayo yung chicken. Okay? So I think I have other questions that I have here. So an orbital can hold 2 electrons. So you can have this. How many 2-pair orbitals are there in an atom? So 2p, anong ibig sabihin yan? Ano yung value ng L? If you have a p orbital,
One po,
ano
sir.
value? 1. So that means if you're going to use the formula, that's 2L plus 1, right? Franklin, question? You're raising your hand?
Ano sir, answer po dapat ako kasi na-delay po.
Rex? I think someone's raising his hand. So if you have that, so 2 times 1 plus 1, so meron kang 3. So kaya nyo ng ano ito? They usually have this question in the exam. Maybe wala sa quiz ko, pero at least iba na yung handa. Okay? And then how many electrons can be placed in the 3D subshell? So this is a subshell. So when this is a subshell, this repels to the D. So maybe you can have the 2L plus 1 times 2. Am I right? So what's the value of D?
2 po.
2. So that means 2 times 2 plus 1. So you have 10 times 2, 20. Oh, not 20. Napakataas naman. 5 lang pala to. 2 times 2. 10 lang. Sorry. 5 lang pala yung times 2. Masyado akong advanced. So, tanong. Kaya ba? Yes, Lennon.
Sir, yung po sa ano, yung pong pag ang formula lang po na gagamitin ay 2L plus 1. Yung po ay pang-determine po ng number of electrons.
Hindi. Orbitals yun.
Orbitals po.
Tapos pag electron, since each orbital may dalawa, i-multiply mo ng 2. Yung 2L plus 1. Okay? So, practicean nyo yan. I think meron tayo dun sa module na mga ganon. Okay? Because the next thing that we look is, i-arrange naman natin yung energy ng orbitals. Okay? So, still following yung concept ni Bohr na yung mga orbits, okay, may different energy level. Ganon din dito sa orbital. Okay? And what determines the energy level? Yung principal quantum number. So, yung 1s, okay, that's the lowest. And then you have the 2s or the 2p, and then the 3s, 3p, 3d, 4s, 4p, 4d. So, it's based on the n value. So, aside from the energy level, sabi ko nga, the higher the energy, mas malaki yung size. Okay? Now, the thing is, if you're going to what we call arrange them, kasi dito, we arrange them based on n value. But if you're going to arrange them, okay, following this what we call the filling up method or the Aufbau principle, okay? So ito, sabi ko nga, ito is still what we call doon sa Bohr model. Okay? When the n is just equal. Okay? But to tell you frankly, yung s tsaka yung p orbital, yung energy level niya hindi talaga magkatulad. Okay? So if you're going to look at the exact energy level, ito yun. And as you could see, even though, okay, mataas yung quantum number nito, principal quantum number, kaysa dito, mas mababa yung energy level niya. At dito ina-apply natin yung tinatawag na N plus L rule. So ano itong N plus L rule? We add the first two quantum number. So yung mas mataas, na number, mas mataas yung energy level. Okay? So pag pareho yung N plus L, mas mataas yung may higher N. That's why if we're going to compare 4S with 3D, ano yung number na makukuha natin? Anyone? So this is what? 4 plus 0. Right? At ito ay 3 plus ano?
2 po.
2. So ito ay 4, ito yung 5. Kaya kikita mo, mas mababa ito kaysa dito. Following the so-called N plus L rule. Now, ano ibig sabihin nito? Okay? So sabi ko nga, energy depends on N plus NL. So kapag meron kang electron, pipill up niya yan, depende doon sa energy level. Unless, still applying Bohr concept or Bohr model, unless energy is absorbed. Na kung saan, pwede yung electron mag-jump doon sa higher, sa orbitals na higher energy level. Pwede yun. Okay? But the way that we do this is this yung tinatawag na Bohr principle, yung filling up principle. Okay? So as what we call proton are added one by one to the nucleus to build up the elements, electrons are similarly added in the atomic orbitals. And usually yung most stable arrangement nila, one electron. So you could see here, pag dalawa na yung electron. So pipill up mo muna sila pa konti-konti. Okay? Now here, may isa tayong ano dito. So why is it in the p orbital, which is made up of 3 electrons, kapag nag-fill up tayo ng electrons, hindi yung isang orbital agad ang pinupuno. You have to what? Share them. Okay, the most stable arrangement of electrons in subshell is the one with the greatest number of parallel spins. So kapag merong additional electron dito, hindi mo siya ilalagay dito. You have to have a parallel spin. So this is following what we call Hund's rule, Friedrich's rule. Okay. So once you have filled already yung orbitals, saka pa lang siya mafi-fill up yung isa. Kasi itong mga orbitals na to, ano yung term na tinatawag natin dyan? Degenerate orbitals. When we're talking about degenerate orbitals, they have the same energy level. And based on the Hund's rule, you have to half fill first before you fill them up. So you have to distribute the electrons first as much as possible. Okay? And once you follow already the sequence on how to fill up the electrons in the orbitals at increasing energy level, pwede ka na magsulat ng tinatawag nating, ano yan, electron configuration. Okay? So it's just easy to kung hindi nyo memorize, you have this, arrange all the S, arrange all the P, arrange all the D, arrange all the F, and then you follow the line diagonally. And i-follow mo lang yung sequence, okay? And then i-add mo lang yung electrons na nandoon. So if you're going to look at the sequence, this is how it looks like in terms of increasing energy level. Ito yung electron configuration. And if we're going to look at the electron configuration, this is how the electrons are distributed among the various atomic orbitals in a given atom. So in electron configuration, meron kang principal quantum number, okay, yung angular quantum number, and the number of electrons in an orbital or subshell. So if you have an orbital diagram, pwedeng ganito. Okay, either you do a box, a circle, pwedeng ganyan, or a line. It's up to you. Okay. So we have this electron configuration of magnesium. You go to the periodic table. Okay. Sometimes it's much easier if you use the periodic table if we go there. Okay. So you have 12 electrons. So all you need to do is fill up the first 12. So kapag meron dito, pwede nating i-fill up 1s2, 2s2. 2 is the max for S, and then 2p6. So ilan na to? 10, and then you have 3s2. So if you add all of this here, that should give you 12. You can write it in terms of this, what we call noble gas abbreviation. So this one is equals to neon. So ilagay mo na yung neon. So it's understood. Okay. So that. And then what are the possible quantum number for the last outermost electron in fluorine? So if you're going to look at this, you have 17 electrons. So ituloy mo lang yung dito na ginawa mo. So 2, 2, 6, 2. So how many you have there? 12 plus 17 minus 12. So you can put a 5 there. 17 electrons. Now, what being asked here, what are the possible quantum numbers? So anong ibig sabihin niya? You go at the last. So you have a 3 and a P. So anong pwedeng ano doon? Okay? N is equals to 3, L is equals to what? 1, and M sub L is equals to either of these three. Okay? And the last quantum number, either a positive 1/2 or a negative 1/2. So yan yung possible set ng quantum numbers. So if we're going to look at our electron, the outermost subshells being filled, so mas madali na tingnan. So lahat ng S doon sa first 2 rows per column. Lahat ng P doon sa last 6. Tapos ito yung D. Now you might ask yourself, bakit yung D hindi kahilera nung 3 dito? So when you have a D orbital, is always n-1. So kung ano yung n dito, -1 yun. So itong 4 naman, dito yan papasok. So when you have an F, it's n-2. So kung 6 yan, papasok yan. So that's 6 minus 2. That's equals to 4. And if you're going to look at this, these are what we call the electron configuration. And usually there's always an exception to the rule, which I discussed doon sa video. Okay, I think it's the copper and the cobalt. Okay, so imbes na mapuno sila sa S, pumupunta sila doon sa D orbital. That's what they saw experimentally. And last part here, you can determine if your given atom will have magnetism or not. Okay? So whenever you have this presence of the unpaired electrons, meron kang paramagnetic. Okay? Sa Tagalog, parang magnetic. And if you have this what we call paired electrons, so if you have unpaired electrons, meron kang isang ano doon na walang kapares. Okay? Now, if you have what we call diamagnetic, okay, these are where electrons are all paired. So from the word itself, okay, dayang magnetic. So walang magnetic. Kung may magnetic man na daya. Those terms I cannot use here because walang katapat dito sa language na yon. Okay, so you might be given question, which of the following is diamagnetic or which of the following is paramagnetic. So when you have unpaired electrons, that means it has magnetic properties or magnetism. If it is paired, then it has no magnetism. So question. Yes, may nagtaas ng kamay. Hindi ko lang makita kung sino. Si Rex.
Lang po sir. Question lang po sa may ano. So, may pagkuha lang po ng spin quantum number. Medyo nalilito lang po din.
So the possible value of the spin quantum number is just either plus one half, positive plus one, plus one half or negative one half. So whenever, let's say, we go with the chlorine, right? So yung ano dyan, if you're going to look at this, you have three quantum, 3, 1, negative 1, 3, 1, 0, and 3, 1, positive 1. So all of them is what? In the p orbitals, right? So kapag ito yun, meron kang dalawang set yan. Either that one or, so kapag ito yun, for each of the orbital there, it either this one, for one of, not one electron dito sa orbital na to, or this one, which is for the other electron. Remember, one is going up and the other one is going down. So kapag dito naman, plus one half, yung isang electron doon sa orbital na yun, and yung isang, ano, yung positive one half at negative one half, it just tells you that in a given orbital, meron kang at most dalawang electron. At yung dalawang electron na yun, dapat opposite spin.
Okay po. Thank you po.
Example dyan, let's say hydrogen, right? And He. So nasa isang orbital sila. Yung isa ganito, yung isa ganito. So to describe, to differentiate them, maybe this one can have this. And this one can have are they the same? So this one can describe this one, which is the hydrogen, and this one can describe this one, which is the helium. Klaro ba? So
Medyo po.
question. Ang problema nito, baka tapos na yung quiz, hindi pa available yung ano, kasi system ko yung ginagamit. And usually, wala nang ano yung space yung computer ko. So, iaano dun sa cloud namin. Tapos, i-email sa akin na available na. Tapos, i-download ko. Tapos, i-upload ko pa. And by that time, may klase na ako sa kasunod na section. So, tanong. So, i-open ko muna yung quiz nyo. And doon sa ngayon lang na sumali, I want you to stay. Okay? And we talk about what we need to do. So I want to see if you already see the quiz. If you go to Canvas. Nakikita ba? So there's 3 questions. One of them is a problem, which is 2 points. You have 15 minutes to answer them. And I'm giving, I think, until 12 o'clock. So we have 1 hour to do that. So kita ba? Nakikita niyo yung quiz? I just opened it. So I'm going to turn
Kita
off,
po, sir.
I'm going to turn off the recording.